To find horizontal asymptotes, you need to remember do not factor. In fact, everything needs to be distributed. To find horizontal asymptotes, you simply look at the problem, and it all depends on where your highest power is. So for example, if we say the function is p of x over q of x, where p is the top and q is the bottom. There's a function on top, function on bottom. If the degree of the top is less than the degree of the bottom, in other words, if the highest power is in the bottom, then there's always a horizontal asymptote at y equals 0. Highest power is in the bottom. There's always a horizontal asymptote at the x-axis, at the line y equals 0. That's known as the x-axis. Case 2. If the highest powers in top and bottom are equal, if the degree is the same on top and bottom, there is always a horizontal asymptote at the leading coefficients divided by each other. We say the quotient of the coefficients. That's the one that's going to probably give you a little bit of trouble, but once you see it a couple of times, it should make sense. So just hang in there. In case 3, if the power is higher in top, there is no horizontal asymptote. Ooh, I left off the word asymptote. Sorry about that. That's highest power in the top. Any questions about horizontal asymptotes? You guys got that? Okay, so those are the 3 things that can happen with horizontal asymptotes. So let's take a look. Just for this example, I want you guys to go through and see if you can figure out what the horizontal asymptotes are. I'll pause for a second and give you a chance to jot it down and see if you can do it without my help, and then we'll go over it. So for part A, the highest power is in the denominator, which means there's a horizontal asymptote at y equals 0. That's your x-axis, by the way. For part B, the powers are the same on top and bottom. The highest power on top is 2, the highest power on bottom is 2. So there's a horizontal asymptote at y equals the quotient of the coefficients of the highest powers. So what is the coefficient of this guy? And this one is, so it's y equals 3 over 1, which is just the line y equals 3. That's what it's talking about when it says the quotient of the coefficients. And finally, for part C, where's the highest power? In the top. So we say there is no horizontal asymptotes. We say none. And it's just that simple. Vertical asymptotes and holes take a little bit more time. The horizontal asymptotes are very easy. You can just look at them. So if you're trying to find all of the asymptotes, it's generally best to just go ahead and do the horizontal first, then do the vertical. Got it? Excellent. That brings us to slant asymptotes. The third type of asymptote is called a slant asymptote. They're a lot less common than vertical and horizontal. I'll go ahead and tell you that horizontal asymptotes and slant asymptotes cannot coexist. Okay? These only occur, slants, if the power of the top is 1 more than the power of the bottom. And as its name implies, it is a slanted line, neither vertical nor horizontal. It'll be of the form y equals mx plus b, rather than just x equals a number or y equals a number. It will be something like y equals mx plus b. And it only occurs when the power on top is 1 more than the power of the bottom. So now that we know when there's a slant asymptote, we need to talk about how to find it. How to find the slant asymptote. To find the slant asymptote, you simply divide the top by the bottom and ignore the remainder. And you can use long or synthetic division to do that. And we'll go over that. Since we probably haven't done that since Algebra 2, we'll go over those in our next example.